slide, make sure you're recording. All right, now recording. All right, so we're going to talk about discrete random variables. Honestly, the biggest part of this is going to be the binomial distribution and some of the calculations around the mean and standard deviation of those. So it's going to be a little more formula driven and more calculations than just definitions of those type of things. It's going to be a lot more calculations. That's why I said I think the chapter 4 and chapter 5 test is going to be a little bit easier because it is more calculation based than explanation based, which the first test there was a lot of interpret this, describe this, like those type of things. And I was pretty lenient on those things, on how I was grading them. As long as what you put was kind of right, I basically gave you the interpretation piece. So I wasn't a total stickler on those things. All right, so let's start. Couple quick definitions because you're going to hear these talked about. And making sure you understand what they mean. A random variable is a quantitative variable whose value depends on chance. So the outcome of a flipping of a coin is a random variable because its value depends on chance. One of the things we're going to look at is actually mortality. It's like, what age do people pass away and die? It's like that would be, as crazy as it sounds, it's pretty much chance. There's things you can do to tip the scales in your favor, but a lot of it ends up coming down to chance. So we're going to look at some of those things, but that's basically what a random variable is. So it's something that, again, I have to be able to identify a numerical value because it's quantitative, not qualitative. Discrete random variable is a random variable whose possible values can be listed. So we're talking about the coin, I can list those. You have heads or tails, which I can easily reduce down to zeros and ones. All right. So heads and tails technically wouldn't be quantitative, but if I listed it as 0 or 1, it would be. Rolling of a die, you got 1 through 6. Those are quantitative values that I can do calculations with. And that's where we're going to start to look at them. When we start to do the calculations with them, it has to be a numerical value that I'm going to look at. Can't just be, oh, what's heads? It's like, how many heads did we get? How many tails did we get? Those type of things. Because now it's quantitative and a numerical value than instead of just a H or a T. And there can only be a finite number of possibilities. So we can't say all numbers because that's forever. Rolling of a D20, a 20-sided die. You have 20 values. That's a discrete value. Oh, I can wait. I still see people writing. All right. So we're gonna. The numbers in the table are a little less important. So x equals x denotes the event of the random variable x equals x. X equals x. There's a difference in the size. So the capital X is actually it stays there. The little x is what we get replaced. So in this case, my siblings is 0. So that would be x equals 0 for that, or x equals 1 for that, or x equals 2. So the little letter is the little x is the one that's going to be replaced. If we put the P in front of it, we're talking about the probability that that event occurred. So for example, what's the probability that I have one sibling? So it'd be capital X equals 1, and the probability would be 0.425, which is the number right there. That would be the probability that that event would occur. I will write that now because as I'm standing over there, I'm like, I might want to write this. So x equals 1 would be 0.425. And the probability that x equals 3 would be 0.075. Okay? So it's the probability that the number of siblings would equal 3, because the number of siblings would be the big X value, is 0.075. Does that make sense? Because part of this is actually understanding what the notation is, because that's what we're going to start to see. It's just like the A and B and A or C, those type of things. We're looking at the notations. They're going to ask you to write the notation and then give me the answer based on that notation. So understanding what the notation means is actually very important for this. All right. So a probability distribution is just a list of all possible values and the corresponding probabilities of those. So I'm going to switch back to here in a second. That table is a probability distribution. It gives me all the possible outcomes and their probabilities. Okay, so that would be a probability distribution. A probability histogram is I take that and I draw a histogram. All right, that's it. I take what's there and I draw a histogram. Remember, histogram has the values down the bottom and the bars are the relative frequency, which is in essence the exact same thing as the probability. And if I'm right, yep, my next slide actually shows that. Every so often things come together. All right, so the first one was my relative frequency table. That is my probability distribution. And right there, that is the histogram of that. Notice the connection between it. One sibling was 4.25 or 0.425, and it goes up between 0.4 and 0.45. Now, sometimes they gave me the relative frequency of this one, but we could have also found the relative frequency by just dividing the frequency by 40. So if we did 8 divided by 40, we get 0.2. 17 divided by 40 gives you the 0.425. So just like we were doing before with relative frequency, sometimes they won't have that calculated out for you. You'll have to figure that part out. So we could do that. All right. Now let's look at some. Because I can actually draw that pretty easy. All right. So if I'm going to toss 3 coins, what is all the possible ways that I can toss 3 coins and get? What are the possible outcomes? So each one is a heads or tails, right? So my first possible outcome would be heads, heads, heads. So then heads, heads, tails. And then heads, tails, heads. Heads, tails, tails. And then now, right. So no, actually, let me finish writing them all, and I'm going to show you there's a very specific way to write these so you never miss one. So when you're writing a list of values like this, notice how I only changed one thing at a time. So the first one I did all heads, right? The second one I changed the very last one. Then notice how the last one basically goes heads, tails, heads, tails, heads, tails, heads, tails. The middle one, heads, heads, tails, tails, heads, heads, tails, tails. And then heads, 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 tails, tails, tails. So it's like, do it in some kind of a pattern that you're going to be able to make sure you hit every single one. So like if you go, oh, I can go 3 heads, or then I can do tails, 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 then I can do tails, tails, tails. Odds are you're either going to repeat something or miss something. So figure out some way that you can make sure you do your pattern so you can hit them. All right. And that's one of the things, especially heads and tails, like coins, they use all the time for this type of stuff. So.
Because right away, the third one I was doing heads, tails, tails.
Yeah, it's like when you're looking at it, look for the patterns that have, and it's fine. You can do it other ways, but you just have to make sure you hit every single one. All right. So that is the all the different options there. We want to write, the first question says use random variable notation. Remember, that's the P with the parentheses x equals whatever happens with the little x. So random variable notation is x equals little x. So we wanted to show that exactly two heads are done. So since it's two heads, that's going to be x equals 2. So notice how now we've taken a qualitative thing with heads and tails and made it quantitative. Now we're only looking at how many heads that have occurred. So we want to know what's the random variable notation for two heads. And that would be x equals 2. The next question says, what's the probability of that? So we want the probability. A. So we want the probability of x equaling 2. So how many times did two heads occur? So it says exactly two heads. So we've got one. Oh, hold on. Let's do this. We got 1, 2, 3. Okay. There's when you asked, exactly two heads, right? That first one has two heads, but it actually has 3 heads. So when you're looking at it, this one would be x equals 3, not x equals 2. Because in essence, we're counting how many heads there are. Okay. So we've got 3 out of 8. So it'd be 0.375. Just rewrite this real quick. All right, so the next question asked us for the probability distribution of x. So we're now looking at the probability of x equals 0, the probability of x equals 1, probability of x equals 2, and the probability of x equals 3. Okay, so when we're looking for a probability distribution, we're looking for them all. So how many times does heads not occur at all? 1. So 1 out of 8, which equals 0.125. How many times does heads occur once? So it looks like 1, 2, 3 times. So 3 out of 8, which is 0.375. How many times does it occur twice? We just did this one. That was 3 times as well. And how many times does it occur 3 times? Once. So 0.125. What should my probability distribution add up to? 1. So the sum of those should always equal 1 because you've hit every possible outcome. Okay, and if you do that, that does equal 1. Okay? So that would be our probability distribution. If I wanted to make this a histogram, I can now make this a histogram as well. Didn't ask for that as well. Okay. Any questions with trying to figure that part out? You good with that? Okay. All right. The next one says use a random variable notation to represent the event that at most 2 heads were tossed. So if I want at most, what's going to be my symbol in the middle? So which numbers work? If I'm saying at most 2, we're going to have multiple things that are going to work for this, right? Which numbers would work? 0, 1, and 2. So which of the 3 symbols I'm going to put in the middle? Actually, there's actually 5, but equals, less than, greater than, less than or equal to, or greater than or equal to. If 0, 1, and 2 work, 2 works, so it's got to have the equal part, right? Is it going to be less than 2 or greater than 2? Less than. So I'm going to put less than or equal to in there. So it's x is less than or equal to 2. Does that make sense? So if it says at most, you're typically going the other direction. If it says at least, you're going greater than it. If it doesn't say, if it says greater than or less than, those are the only 2 words that would make sense for this. You don't put the equal sign there. So if it's greater than 2, 2 does not work. All right. So if it said greater than 2, it would only be 3 in this case. If it's less than 2, it would only be 0 and 1. If it says, if it's between 2 and, or actually, if it's between 1 and 3, if it says just between 1 and 3, the only answer is 2. So it equals 2. If it says between 1 and 3 inclusively, then it's 1 less than or equal to x less than or equal to 3. It'd be all of them. Okay. So if it has that word inclusive, that means you're including 1 and 3. If it just says between, you do not include those 2 numbers because that's not between the 2 numbers. So it's little things like in the wording on how it's wording to ask you those questions, to ask. And sometimes it's honestly easier just to figure out which numbers would work in it and then come up with your symbol that would make sense. So that's kind of like what I did this one. I said, what numbers are less than or at most 2 with 0, 1, and 2. It's like, okay, now what symbol makes sense when I say that? All right. So sometimes that will be a nice little way to do it. And you don't necessarily have to come up with huge numbers. It's like if it says we're looking at ages and I want to know what's the probability, or with ages that are less than 50. If you're not going to list them all, it's like, okay, but 45 would be work, 37 would work. Okay, so I want the less than symbol there. So it's like pick a couple of numbers to start figuring out which direction it's going to go. Okay? The next question says, what's the probability of that? So I want the probability that is x is less than or equal to 2. So how would you do this one? So remember, we've got all our probabilities right here, right? So if I want less than or equal to 2, which ones am I looking at? Yes. Okay, so I could take 0, 1, and 2. And if I add those 3 up, I would get my answer, correct? So in this case, that's 0.875. And I brought a calculator today because I still don't trust you. All right. What's another way I could do this? You already gave me the first way. There's another way we looked at with probabilities. What do they all have to add up to? 1, right?
Subtract the one you're not using.
Yeah. Sometimes it's easier to take away what you're not using than to add up a whole bunch of numbers. Okay. So in this case, it was 3 numbers. It wasn't that difficult to do, but technically 1 minus 0.125 is easier to do. And it will give you the exact same answer. So you can do either direction depending on what it is. But if it was like a 20-sided die and I wanted, what was the probability that was less than 19 or less than 20? I'm not going to sit there and add 0 until all the way up to 19. I'm literally just going to do 1 minus the 21 and save me that extra work. So those are the types of things you might want to look at. Okay. Saves you time, saves you energy. All right. Any questions with finding the probability in those things? We've now finished section 5.1. Okay. This is what I said. I don't think this one is overly complicated. All right. Just like we did before with other calculations, we need to be able to figure out our mean and our standard deviation. So there's the standard, there's the mean. So you can write that down. The key thing is the formula in the middle, which I will explain how that works in a second. All right. So the mean, so that little E symbol, everybody remember what that means? Yes, that is summation. Okay. That is the sum of X times the probability that it would occur. Okay. Both of these things can be gotten from our table. There is not an easy calculator to do this. This is actually easier just to do it out by hand. So unfortunately, there's not simple calculators to do these. But the calculations are pretty simple. So once I go through and do the process, it's not that bad. All right. So let's do that. So here's our table. So we want to find the mean. I don't remember which table this one was. Hold on, I can give it to you. I think this is example. I think this is example 5.7. Yeah, this is example 5.7. Wherever that happens to be in your book. It's section 5.2, which is there you go. Yeah, it's the busy teller's problem.
Yeah, where you were.
Yeah, there's an extra column,
Okay.
which I'm about to do.
Okay.
I wanted to show you how that extra column existed. So you're fine. All right, because that's actually the piece that you're going to do. That's the calculations you're going to do. And why is this not letting me hit my marker? Okay. All right, so the mean was the summation of X times the P of X equals X. So we want to come up with those values. You have, in this problem, you have X and you have the probability. So all we're going to do is actually multiply those. So in this case, it's 0 times 0.029, which equals 0. The next one, 1 times 0.049 equals 0.049. Huh? 0.078. Oh, geez, my calculator literally, it does it all in fractions. 0.156. 3 times 0.155. 0.465. 4 times 0.212. 0.848. 5 times 0.262. Notice, yes, it's a bunch of like multiplication, but it literally is just multiplication. 1.310, and then 6 times 0.215 is 1.29 up. That was that extra column that was there. All right, that's all they did. Yes. Summation. That's the only thing I haven't done yet. Summation. It's basically we're going to add up a bunch of things. So that's the only thing I haven't done yet. So this right here is the x times the p of x. The p of x equals x. So that's basically taking those two columns and multiplying. Now all I'm going to do to get the actual mean is add those up. So obviously 0, I don't have that up. So we get, for this one, this equals 4.118. So the mean number of siblings, or actually, sorry, this one's bank tellers, right? Yeah. The mean number of busy tellers is approximately 4.1. So multiply them, add them up, and that gives you your mean. All right. Any questions on that? Okay. So that's how I find my mean for a probability a discrete random variable probability distribution. Here's the standard deviation. Standard deviation looks more complicated. It is a little more complicated. But it's very similar to what we were just doing. When you have to do these, you're not going to have to do these when there's a million different values to do it through. Right? The ones you're going to have to calculate out are going to be pretty small. If you're going to actually do this in a career, you're going to use a computer to do anything more complicated than this. And if you're really good with Excel, you could just do this all in Excel and have Excel do all the calculations for you. It's not really difficult to do that. You're just not going to have that on your test. Huh? You're not going to have access to Excel now. Oh, it's me. I'm like, wait. Yes. Super. So exclamation point at the bottom. I'm like, oh no. All right. So your standard deviation, I would not use this one. It'd be a little more of a pain in the butt to do. We're going to use this one. We're going to use the bottom. Because you're already have calculated out your mean. No matter what you're going to do these, you're always going to have your mean already calculated out. So there's no need to do that calculation again. We're basically just going to do this first part and plug it in. The only thing that changed from what we had just done is my x is now squared. That's actually the only thing that changes from what we just did to what we're going to do. Okay, we're just going to square the x before we multiply it by the other number. All right, everybody good writing this down so we can actually try it?
Yeah.
We're changing her name to everyone. I'm just kidding. All right. So we're going to do all we're going to look at now is we're going to do the x squared part. So it's x times the p x equals x. Okay. So x squared, that's 0, that's 1, 4, 9, 16, 25, and 36. Right? Just multiply the number by itself. Okay? And I wouldn't try to do, like, I would do it just like I did there. I wouldn't go through and say, okay, now I'm going to do 0 squared times this number, 1 squared. Just do the squares pretty quickly. Those are something that you can do pretty quick. All right, now we're just going to multiply. So the first one is 0. The second one is 0.049. Then 4 times is 0.312. 1.395. 3.392. 6.550 and 7.740. If anybody's wondering how I'm typing these in my calculator so fast, I'm not putting the decimal points. I just did 0 times 29, or I didn't do that one, or 4 times 78. And then I know it's 3 decimal places, so it's 0.312. All right, save your typing and getting the 0 point and all that other stuff in there, and or missing where you're putting the decimal point. Some of those things, when you're looking at calculators, the more you start to work with it, those little tricks will save you time and save you making a little mistake on where decimal points are. You just have to remember what your answer should look like. I knew in this one that my answer was going to have 3 decimal places, so whatever I got, I was going to make the 3 decimal places. So, like if I multiplied 1 times 49, I know it's going to have to be 0.49 because I want 3 places. So. And then the ones that came out to be 4 numbers, I knew one of those numbers was going to have to be in front of the decimal point. All right, so next, do exactly what I just did in the last one. I'm going to add all these up. So the summation of that is 19,438. All right, so my wonderful square root formula. We remember it was the summation, right? Minus the mean squared, all under the square root. So the summation I got was 19,438. And my mean was 4.118. So 4.118 squared. Now, depending on how your calculator works, if you're using the Desmos calculator, which is what I'm about to show you in a second, you can type the whole thing in at once. My answer is going to be 1.575. Like I said, depending on the calculator you have, like this one, I can even type the whole thing in. And it gives me the final answers. So depending on how you want to set it up. Yes.
Is squared all?
So yeah, if you're to do the whole square root, just put it in parentheses. Depending on how your calculator is set up, you might have to put parentheses around it. On Desmos, it will assume you're staying in the square root until you click out of it. So notice how, like, if I press out, now the number's not under the square root. So it'll automatically type anything under the square root until you click out. So, and you can tell once the little line stops moving over your thing, you're not out of the square root. So, all right. Yes.
4.118.
That was your mean. So we got that here. That's why you have to come up with your mean first, and then you have to do your standard deviation. And that's why this formula works, splitting it up, is because you already did the whole summation for the mean, so it doesn't need to have you do that again. So this one was, what was it, 1.5. So that's my standard deviation. Awesome. We're done with section 5.2. Yes.
So we can use the calculator.
Yes. You're going to have to. There's just, I don't have a simple calculator to say, here, find the standard deviation of this. Because the only way it's going to work would be, you're going to have to type all this anyway into the calculator, and it's just as fast to do the calculations out real quick. So it's unlike the other one where you just type the numbers in and it gives you the standard deviation. This one, you have to do a bunch of calculations for it, so it's just easier to do it out. So. All right, actually, I want to actually have you guys do one of these problems.
To clarify real quick.
Yeah.
So you added up all of those numbers and you got 19.438. And then you're subtracting the mean from that question before.
Yes.
Okay.
Yep, the mean squared. So that's why it's 4.118 squared.
Oh, okay.
Yeah, it's the mean squared.
And that's how you get 1.5.
And then you do the square root of that, and that's how you get the 1.575. All right. All right. Since I'm moving through this pretty quickly, actually, I want you guys to actually try one of these. All right. So I want you to find me my mean and standard deviation for this probability distribution. sure. If you're looking in the books, it's exercise 5.31 and 5.2.
What?
Section 5.2, exercise 5.31 is the one I'm gonna have you guys do, huh?
I'm good.
Okay. So if you can't see the numbers on the board, that you can look in your book and get it. I want you to find the mean and the standard deviation of it. Does everybody have the numbers down? Okay. Just because I want to mute it so I could actually go through and do the calculations on the screen. So when you guys get the answer, I can show it to you. And I can't do that. Okay. Okay. No, but I did. Okay, I literally just messed up that one. That's right. You can't do that. Oh, so just honestly, just use either Desmos, you can just go to Desmos.com, or you can just literally have to do that. Desmos.com. This one's actually easy. So you can do the start. And then you can take it. There's a and then
So. That's right.
Well, okay.
Or that.
No. I'm trying to figure out why mine's coming out wrong.
You're making the ooh no noise.
No.
Just give me extra time.
Oh. It's 9-3, not 3-9. That was the mistake on your on the calculator, which I typed in. So you're fine. Wait a second. You have it right in there. I typed it wrong in your calculator. I switched to 3-9. You're good.
The book rounded it up. I thought it-
So then,
That's right.
all right, so then, and then we go to this second.
Yep. Now you have to do the standard deviation part. So you're gonna do the exact same thing you did here, except you're gonna square those numbers. So it'll be 4 times that, 16 times that, 25 times that. That's right.
Oh,
So what did you like? So. I want to look for it. I don't know. I think so. Most of them look fine, but okay. Those should be the numbers. That's 6. That's 1.33.
Oh, yeah.
And believe it or not, that's the only mistake. Just that one little thing.
One digit.
Yeah. Well, don't worry. I screwed up because I had, so what I ended up doing, I said, oh, darn, I messed it up. So, because I was doing my table at the same time, which I didn't tell you before. So I did 2 times that, got that. And then I did 4 times that to get 240 there. I'm like,
Oh, okay.
the little things. I'm like, the answer was wrong. So I go fix it all. It's always the little
Glasses, I can't see. Oh.
It's like on her calculator, I reversed the 3 and the 9, 37.93. I put 37.39. So it's like the little things can make a big difference when you're doing these. And that's why I said when you're going through doing these, even on the test, show out all your work. Because if your process looks fine, but your answer comes out to be wrong, you're going to get the majority of the points. And then I will try to figure out where your mistake is. Sometimes I can. Sometimes it's just going to take me too long. I'm going to say, something's wrong here, but you're good. I'll give you the most points. Also, if you notice on the test, your next test will be graded the same way. Each question's worth the same amount of points. Each question's worth 10 points. So even if there's 15 parts to this question and none to this one, they're both worth 10 points. So keep that in mind when you're going through and doing your problems. There was quite a few problems towards the end that I know people skipped, and they weren't that difficult. And I'm wondering if you just ran out of time because you spent so much time in the beginning ones. It's like, go through and look at the questions and sometimes spend more time on the easier ones first, and then go back to the ones that are going to cause you a little more trouble. So, all right. So again, all this is just, it's a lot of little calculations. Okay. And it's how are you going to organize your work to find it? Huh? Oh, yeah. Like it's just, and as we've now learned in 3 or 4 different people, it's the little things that can make a difference. Okay, so even on my end. And that's happened. Like, I'll go through it, I'll do out my answer sheet, and then when I start correcting papers, I notice things, I'm like, wait a second, did I screw up? And I'm like, oh, I did. Here's a perfect example. On the last test, people started getting an outlier, 3.3, and I'm like, then I look back on my paper, I'm like, oh yeah, that's an outlier. And I fixed my answer. So it happens. This is why we check things. So this is why I have a team of 4 people underneath me now that are checking all the work in my books. So it's like, that's what you do. All right. So that's the mean and that's the standard deviation. Okay. I don't believe you do have one of these on your practice test too, but trying to figure out, remember how many there was on this one.
Just go in order. But it's really like 5 squares. 6 squares.
Oh yeah, the one on the test I actually has 3, so it's not that bad. 37.93, yes. And then minus the 6.050 squared, you got 1.152. And no, you don't need to write the extra zeros at the end if you don't need them. I just, for consistency's sake and the way I'm doing them on my calculator, I'm keeping everything to 3 decimal places. It's just consistency. If you had put 6.05, I'm not marking it wrong. It's right. Okay? It's just, how are you using that when you do the stuff in the calculator? Oh, absolutely. No.
You're not alone.
I'm using a calculator. So yeah, if you want, you can either bring your own calculator, or if you want to download Desmos onto your phone and do it right on there, the Desmos Scientific one, you can do that. That's fine. Yeah. Yeah. So just download Desmos, this app. It'll download right to your phone, or you can literally go to the website. It does the same thing. So depending on what you want to do, but yeah, definitely just do that. Your phone actually can do it. It's just a lot more difficult to do it on your phone. If you turn your phone sideways, it gives you all the scientific information. It's just harder to see because it doesn't put the nice parentheses and stuff around it. So it is definitely easier with some of the other apps. All right. Any other questions with this one? Okay. Sure.
I got the mean wrong.
Check your numbers. It's probably one calculation that's off.
Oh, it's close.
Yeah.
I got the 7.
It's probably like I think somebody back there missed the 3. It was 1.035 instead of 1.335. Like that one little thing.
I'm trying to do it so fast. So
Yeah. sometimes just slow down, look at your numbers. Like I said, I even screwed up this one. I did 4 times 0.6 instead of 4 times 0.03. It was like, it was a quick little mistake because I was trying to write it down quick. So it happens. And that's why I said, write out all your work and then you'll get it a little bit better. All right. Keep this. All right. Find it?
Yeah, I skipped like a 0 decimal.
Yeah.
So it came out higher.
Like I said, it's little things. It happens. No, don't worry. It actually does. Again, the scientific part does. But you're not going to do that anyway. You're going to see this in the book. You're going to see with parentheses and the N over the R. Okay? You'll see that in some of your problems. You'll see that in some of your answers. That literally means this. And if you look in the book, they give you that formula. However, we've already done this. It's NCR. Okay, so remember back when we did the probability, we did NPR and NCR. Those two, and I showed you on the Desmos calculator how to do it, and it's just you literally put the NCR and then put the numbers next to it. It is the exact same thing. Okay, so if you see this, and we're going to do a couple problems with this, we're just going to use the NCR behind on your calculator. You do not need to do the factorial problem in the middle. Okay. It's like sometimes they make life difficult and it doesn't need to be. So, for example, let's do 7.3. So if you see 7/3, that is 7 choose 3. And you're going to type it in like this into Desmos or whatever scientific calculator you're using. Yep. That's literally what you would type in. And the answer in this case is 35. Yes. Yes. It's under your probability menu. Yes. It's crazy. I used to use those all the time. Like everybody, it's so long since I've actually used a real TIA calculator. Because everything I've done for like the past 6 years has been on Desmos and stuff that I have to actually remember where they are now. So yeah, that's what you're gonna do. Believe it or not, that's the exact same answer as if we did that crazy factorial thing. On that calculator, it's hold on, I gotta find it. I have the same one.
I have the shift, and it's right here.
Where is it? Oh, actually, so you're gonna do 7, shift that 3. Shift that and then 3.
No.
You're actually typing it in as what N is, C, and then what R is. You have to put parentheses around yours.
That's what I just did. It didn't happen.
Why?
I tried-
Oh, because you have answered. Oh, you know what? Actually, you don't. you type in 7, then hit that, and then 3. Perfect. No problem. All right. Any other calculators? Anybody's got them? Want me to show you how to get it? Since every calculator seems to be doing it differently.
Oh.
The button for it. If not, I gotta find it. You did right there. All right. So you're gonna hit 7. Shift that 3. So it's right above the division piece. So you do 7, and see how the little C right there next to it? And then 3.
Yeah.
Which is 35. You're going to hit 7, and then math, and go over to probability. It's a 3. And then 3.
That's horrendous. I'll just do it.
Anybody else? It is not. No, it's not. You actually have to use an app for it. That's not one of the scientific pieces for it. Unfortunately, it's not on my Android phone either. So, the basic calculator is a basic scientific calculator. It's not. Doesn't have all the extra keys on it. This is actually just looking for combinations. I'm gonna show you what we're using it for in a minute. So as part of the formula that we're going to do to actually come up with some calculations, you need this piece. They're going to show it to you typically like that with the parentheses. So I want it, really, in all honesty, this part right here is me just showing you what they're going to show you and what you have to put in your calculator. So most people, if you're actually typing in your calculators, you actually are doing this. Desmos does it that way. Most of your actual calculators, people are typing in like that. 7, then the NCR button, and then the 3. So whichever way you do to get 35 in your calculator for that answer, you're good. Because that should be the answer you get. No, I'll show you. No, it's fine. Because we're going to use it. So it's like, if you don't know how to do it down here. Oh, see the PRB?
Yeah.
All your buttons are right there.
Yeah.
So you're going to hit it. 7, PRB, and then hit the second one. So your probability may be at that. Or that. All right. Now that we've gotten that piece taken care of, let's talk about death. Mortality. I told you one of the problems we're going to do today was about death. All right. So when, as horrible as it sounds, pretty much anything that revolves around your life, they use these tables to determine how they should charge you. Okay? So they have mortality tables. They basically have how old you are in a variety of different situations, and this is the probability that you're going to die by this time. Okay? As I said, as morbid as this sounds, that's how they determine your life insurance premiums. That's how they determine what pensions are going to be. That's how they determine any annuities you're going to have. That's how they determine Social Security and all this other stuff. This is why Social Security is running out of money. Because when they initially did all the calculations on it, we weren't living as long. Okay? When they first started doing Social Security, people were living 60s, maybe early 70s. So if you retired at 62, you're maybe collecting for 5, 7 years, 8 years. And now you're living another 10 on top of that. We're about 78 is the average life expectancy now for, so about 8, 9 years. So depending on male and female, it changes a little bit. So the calculations changed. That's why they start upping the years. So now you can't retire and get Social Security until 65 or 67 or whatever it happens to be. Because they're trying to keep it as you're only supposed to collect for a certain number of years. The longer you collect, the more money you're getting out of it, and that does not balance it. Life insurance, same concept. If you're paying into a life insurance policy, they want you to pay in a certain amount that's going to cover what they're paying you out. So they do the calculation, figure, okay, if you're going to your life insurance policy at 25, say they're predicting you to die around 70. That means you're going to be paying into it for 45 years of your premiums. Does that then how much is your premium going to be? They do the calculations based on that. So their goal, as again, horrible as it sounds, is to get more money from you than they're going to give you. Okay? Because that's how they make a profit. But that's also how they cover other people who go the opposite direction. So life insurance policies actually want you to die later than earlier. Because if you die earlier, you've paid less money in and you're getting more money out. They want you to actually live longer than they're predicting. Where Social Security and retirement pensions want you to do the opposite. So these things are used all the time. So according to this table, a person at the age of 20 years old has about an 80% chance of being alive at 65. Okay? So we're going to look at 3 people. We're going to select 3 people, random people at the age of 20. And we're going to do some calculations based on that. Okay? All right. So the first thing is, hold on. I'm going to find my next thing. So when we're setting this up, we got to come up with a way to actually do the calculations out and the setting it up. So if you think about this, we're going to almost do this the same way that we did heads and tails. Okay? We have 3 people, so just like 3 coins. What are the only 2 options they have at 65? Alive or dead, right? So I think they actually use S and F, which I don't really like that. So we're going to use A and D. So A is alive and D is dead. So we're going to set up our table. So we have alive, 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 dead, alive, dead, alive, alive, dead, dead. Oh, wait. Dead, alive, alive, dead, alive, dead, 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 alive, and dead, dead, dead. Oh, there's one in there that's dead. Unfortunately, 2 of them died. Sometimes we just have to joke about it. All right, so we've done basically the same thing we did with the heads and tails. What is the major difference between this and the heads and tails, other than the fact that people are dying and heads and tails are not? What's the major difference in terms of probability?
80%.
Right. Heads and tails is a 50-50 probability, right? 50-50 chance. Alive and dead, you have an 80% chance of being alive and a 20% chance of being dead. So the numbers are different when we're looking at the calculations for it. Okay? All right. We good to there? Take this. I'm running out of tabs. Running out of things. That's fine. All right, so we've got to pick which direction we want to go. So let's think positive. We're going to look at the alive side, because just like when we did with the heads and tails, we need to make these numerical, right? We need to make these quantitative, not qualitative. So we're going to look at the number of people that are alive. Okay, so the probability of alive we know is 0.80. So what's the probability of dead? 0.2. Okay, or 0.20. Okay. So when we're looking at this, we can now work out the combinations of all of these to figure out what the probability of that outcome is. Okay. So actually, let's redraw this. Okay, so we've got the probability of alive, alive, alive. When we're doing this, since these are all independent events, remember that makes a difference, right? If it's independent or not. Since these are all independent events, we can just multiply the three probabilities. So in this case, it's going to be 0.8 times 0.8 times 0.8. So what's 0.8 times 0.8 times 0.8? So we are going to multiply 0.8 times 0.8 times 0.8. Because the probability of alive is 80%, right? So since there's three events and each one's independent, we're going to multiply the probabilities. So it's 0.512. So then we have alive, alive, dead. So it's 0.8 times 0.8 times 0.2. And that's 0.128. And then we have alive, dead, alive, which is the same basic thing. So again, it's 0.128. Then we have alive, dead, dead. That's 0.2 times or 2 times. So that's 0.032. Everybody following along? Okay. And now we do dead, alive, alive, which we already did a couple times, 0.128. Dead, alive, dead. So 0.032. Dead, dead, alive, 0.032. And dead, dead, dead is 0.008. Again, it's just 0.2s or 0.8s. We're multiplying. So dead, alive, dead is 0.2 times 0.8 times 0.2, which is 0.032.
So how'd you get for the alive, alive, dead, and then alive, dead, alive? Is literally the same.
Right, because it's this is 0.8, 0.8, 0.2. This one's 0.8, 0.2, 0.8. Same three numbers. Okay. Yes. Oh yeah, absolutely. Yeah. You're welcome. The answers will be online maybe today, if not first thing tomorrow morning. All right, so what's the probability that two? So we're assuming the alive is the value that I'm using, just like heads, right? So what's the probability that exactly 2 will be alive? Exactly 2. It was 3, but we got to take now. Before they were equal opportunities, right? So it didn't really matter how I did it because I knew they were equal. In this case, since they're different, we have to look at each individual thing and add them up. So when we're looking at this, we want to take the ones that are 2. So 2 alive is this one, and that one. So we're going to add up those 3 numbers. Or so 3, or actually, so 0.128 plus 0.128 plus 0.128. So it's 0.384. So that's the probability that exactly 2 will be alive. Now, if we wanted to do our probability table, to do our, if we're going to do a distribution and then the histogram, remember, we're going to look at each one. So we have 0 alive, 1 alive, 2 alive, and then 3 alive. So we just did 2, it's 0.384. The 3 alive, there's only one of those options, right? And that's 0.512. The 0 alive, there's also only one of those, and that's the 0.008. So now the 1 alive, we have 3 of those. So it's the 0.32, 0.032, 0.032, 0.032, which comes out to be 0.096. So the big difference between this one and the heads and tails is we have to look at the actual probabilities to come up with this anathema. We can't just do 3/8. All right. Now, what we did here works really well when it's a small number of things. Okay. However, if there's a large number of possibilities, this isn't going to work as well. So there's a formula for it. It's called the binomial probability formula. And remember that this is NCR. So when you're looking at this, remember that's the NCR. That's why I spent a little time doing that, because we're going to need that. The P is just the probability of success. Okay? And then the 1 minus P is the probability of failure. So in the problem we just did, that's 0.8. And then 1 minus 0.8 is 0.2. Okay? So that's probability of success, and that's the probability of failure. And then the N and the X is the M and the R, the number of values you have and how many you're choosing out of that value. We'll see how this works in a second. Everybody got the formula written down. Okay. We're going to go back to the problem that we just did. But this time, we're going to use the formula for it. All right, so actually, since we already got that information, I don't really need the rest of it. I just need the problems. All right, so when we're looking at this problem, pieces of information we need to know P, which in this case was the 0.80. Okay. We need to know N, which in this case we had 3 people. Okay, so those are the 2 pieces of information you're typically going to get from the problem, from the information they gave you. The rest of the stuff we're going to get from the question. All right. So for A, we want exactly 2. Now we did that calculation already, right? That was the, what was it, 0.7 or 384. So we already did that calculation. The number we get here should equal the exact same thing. So we want exactly 2. So I'm going to have my NCR. So I'm going to do 3, choose 2. And then my P is 0.80. And I want 2 of those. And then my failure, I want 1 of those. If I want 2 alive, so that's 2 alive, and that's 1 dead. So, I'll show you how to type that into Desmos. Depending on how you type it in. Give me 1 second. Let me type it in Desmos, and then I can go around and show people how to type it in. You'll see how I type it into Desmos, and you have to type it in pretty similar. All right, so that is how I type it into Desmos. If you're doing the other direction here with the 3, so it'd be 3C2, put parentheses around it. And that's probably going to solve the issues of math errors. You also can, hold on. There we go. You also can, you don't necessarily have to type the 1 minus 0.8. You can put in 0.2. Okay, because we know the failure is 0.2. Couple things when you're looking at typing your formula in to make sure you typed it correct. The 2 numbers in the parentheses here have to add to 1. So 0.8, 0.2 adds to 1. The other thing, the exponents up here have to add to the total. So since in this case I got a total of 3, 2 plus 1 is 3. Those 2 things have to happen. Yes. It's the 1 minus 0.8. I wrote it in exactly as the formula is in the book, but you could easily have changed that and just put 0.2 there. It'll do the exact same answer. And typically when I'm typing it to do it out, I'm putting the 0.2. So. All right. And notice the answer is 0.384, which is exactly what we got when we did it the other way, the long way out. All right. For those of you that are using Desmos, or those of you that are not using Desmos that are now going to like to use Desmos, let me actually change these to the correct numbers. Desmos allows you to plug in formulas. So if you notice up here, I have my formula. That's the formula just like you put in the book. Okay? With the N and the R's. Or you can put N and X, because I think they use N and X in the book. Doesn't make sense. And I just put the numbers here. So in this case, I was having 3 choices. I chose 2 of them, and my probability of success was 0.8. It then plugs all the numbers in. It gives me the answer. This works really, really well if you have to do a bunch of them. Okay? For example, in the problem that you're going to have in the review test, I think there's 8, if I remember right. That you have to come up and do the different probabilities for them. So this is actually where this came from, because I did this earlier today. It's really easy, because all I'm doing, basically, everything here is staying the same. The only number that's changing is R. So I was just literally changing the number there, and the answer showed up there. So getting to use Desmos and using that as a formula thing, it does help you save a ton of those calculations. Let's type the formula in and put the answers next to each one, and it gives you the answer. You're going to see how this comes into handy in a second, because we're going to have to do a couple more calculations. So the answer for the first one we did was 0.384. Now B, it says at most 1. So since it says at most 1, which ones are we looking for now? We want 0 and 1, right? So we want 2 of the outcomes. So we want the probability of x equals 0 plus the probability of x equals 1. Right? So if we go back to Desmos, I want the probability of x equals 0, which is 0.008. So I can come down here and type in 0.008 plus, and I want 1, which is 0.096. Yes. Yes. Yep. You can't actually do it with the graphic calculator, it's just not as pretty. So notice I just changed that one number there and then just added the number down the bottom. So the answer to this question is 0.104. Does what I'm doing in Desmos make sense? Yep. So this is the formula I got right from the book. Just literally, if you're doing on your computer, yeah, in your phone, you should have an ABC button on the calculator thing on the bottom, and then all the letters are there.
And when you went into Desmos,
I'll show you. This is what I did.
when you first started.
So I had this. This is the scientific calculator at Desmos. So there's two. There's the scientific and there's the graphic. This is the scientific one. So I hit NCR. Yeah. So I hit NCR and then I put N comma R. And then I did P. Both of them were, well, the graphing was less useful in this class than it will be in other classes. And then I put R. And then I do 1 minus P to the N minus, oh, I have to go parentheses, N minus R. And then you just type in N equals, R equals, and P equals. And you just change the number you want. Actually works for any formula. You could do your, if you were doing volume or area or currency calculations or anything, any formula you have for any class, you could type the formula in there and just change the numbers and it'll always work. So this one we were looking for at most 1. And we've got that value there. The next one, I want at least 1. So at least 1 means what? So at least 1 means what? 1, 2, and 3, right? Okay. Now in this case, doing 3 isn't a big deal. But what's the other way I could do this? Right. So the only one I don't want is 0, right? So if I did 1 minus the probability of x equals 0, I would also get my answer, right? So let's go back to Desmos. So I've got 0. I'm going to do 1 minus 0.008, 0.992. That's my answer. So if you're 20 and I have 3 of you, and I'm going through and doing life insurance calculations, I know that I've got a 99.2% chance that at least one of you is going to be alive at the end. So at least one. So that means it's not one of those look to your left, look to your right, only one you give me. No, it's look to your left, look to your right. There's a 99% chance that you'll all still be here. So when I'm doing my calculations to come up with premiums, I'm making the assumption that there's a 99% chance that all of you are still going to be alive. So if I base my calculations on that you're going to die at 65, after that point, it's all money in the bank for me. Okay? So the longer you live, the more money I'm making. So that's where they do their calculations. They're looking at, I got an 8 out of 1,000 chance that all 3 of you are going to be dead at that point. So it's like, okay, that's a good hedge of my bets. So I'm going to make money after that point. And even the chances of all 3 of you being alive is 51%. So it's even more than half chance that even all of you are going to be alive at that point. So looking at it as, again, that's money in the bank for me. So that's why whole life insurance policies are a bad investment. Because they're betting you're going to live a long time, which is what you want. You're betting you're not.
Yeah.
It's like, right, which you really don't want, because the longer you're alive, the less value you're getting from that life insurance policy. So it's crazy when you start to think about life insurance policies that way. So, but that's what they do. And we're talking about in this case, I could have easily done the exact same thing with warranties. Warranties are the exact same concept, right? They know that after 18 months or 2 years or 24 months or 2 years, whatever else, the thing's going to start to die. Their warranty is to there because they're hedging their bets. It's like they know, like, the chances of it dying before that's slim, so they'll be able to pay you out and give you a new one, no problem. After that point, the chances of it dying are a lot higher, and they're no longer giving it to you. So when the phone companies are making their phones, they know, they are assuming most people are going to upgrade every 2 years. That's what most people do. So if that's how they're calculating out their money on their income strategies and everything else, if you keep it longer, that's good for you. You're saving money because you're getting more use out of it than they're expecting you to. The early adopters who traded in every year are basically costing themselves money and making the companies money. So, which is why they cater to those people, because they're making a lot of money off of it. Even giving you, though, there's like massive trade-in bonuses for your votes. All right. We're going to look at the standard deviation and the mean for these, and then we're done. All right, so here's the standard deviation and the mean formulas. Notice these formulas are actually really simple. Because again, you're only getting, in the problem, they're only going to give you 2 pieces of information. They're going to give you how many things you're looking, like the total number that you can have, the number, and the probability that it's going to happen. That's the only 2 things they're going to give you. So that's the only 2 things they can use to calculate these 2. All right, so your mean is just n times p. That's it. No addition, no nothing. Just n times p. Standard deviation is a little longer. It's got the square root in there, but it's n times p times 1 minus p. So it's n times the success times the failure, and then the square root of that. So for this problem that we've been working on, my n was 3 and my p was 0.80. So my mean is 3 times 0.80, which is 2.4. So the mean is that there will be at least 2.4 people alive at 65. My standard deviation is 3 times 0.80 And remember, 1 minus p is just the failure. That's 0.20. So 3 times 0.8 times 0.2 is 0.693. And remember from our conversation in chapter 3, so a few weeks ago, we were talking about mean and standard deviation. So my mean is 2.4, my standard deviation is 0.693. So if I go out 1 standard deviation, that means 67% of the people are going to fall into this, right? So that means everybody alive to like 1.8 people alive. That's 1 standard deviation. So 67% of people are going to fall into that. 2 standard deviations, we have between 1 and 3, basically, the way it works out. So you can start to look at that. That concept still holds true even for this. When we're looking at mean and standard deviation, you can still do that curve, that bell curve and everything else, because that all still works with this. Right? Yes.
For the bottom.
So it's 3 times 0.8 because that's the success. And then I did the 1 minus 0.8, which is 0.2. That's the failure. Remember, those two numbers should always add up to 1. So the 0.8 plus 0.2 equals 1. So
that's the one
no, the 1 minus p, yes, it's 1 minus 0.8, which gives you the 0.2, yes. This is why I didn't do the 0.2 in the last one. I wrote the 1.1 minus because I knew I was going to wait, where's the 0.2 come from? Yeah, that's where it came from. All right. Any questions with this? Okay. We're done. Nice early night. There's 2 things that you need to start working on though, since I'm leaving, like you're basically getting out of here almost an hour early. You've got your project if you want to do it, the extra points, and the practice test, which I'll give you as you walk out the door. Since I'll be home by 9, I should be able to get the 2 things posted tonight, so they'll be up there first thing tomorrow morning for you at the latest. So I just literally have to go home and scan the document in.
What was the second thing you just mentioned?
I'm going to hand you the review pack
Okay.
for chapter 5, the test. So you can actually do the practice for it. Yep. So, because I literally did out the practice on paper, so I have to scan it. All right, so yep, you can just come grab one of these. It's 10 questions again. They are double-sided, so it's a little smaller. Make sure to try them. I will have the answers online, but make sure to do out the work. This way, when you come in next week, you can ask questions.
Excellent.
For some reason, it's not coming out on this one. So use a different one.
No, you should. 3, choose 2. Why did it come up with 3? That is not the answer we're looking for.
I know. That's why I was so confused. I'm like, I can't coming out. You know, I can download another the other one.
Yeah, I don't know why that's coming up. That's weird because that's actually how it wants you to write it.
Yeah, I'm like, I don't know. It didn't come out before, so I'm like, this is
Yeah, I don't know.
crazy.
That's weird.
So
What's up?
I just wanted you
Desmos.
to show me what I did wrong with this question. real quick.
So this question actually, it wanted you to do 2 things. First off, you did the Chebesky's rule, which is fine.
Yeah.
It wanted you to compare it to what actually happened, which nobody did.
Okay.
Actually, I take that back. I think one person did.
All right.
So basically, it wanted you to see how many are actually between the two values here to compare to
Oh.
actually what.
like,
Trebek-
what is the 75%?
Right. What, no,
Okay.
not even what 75%. What is within 2 standard deviations of the mean here? So actually, hold on a second. I got this. Yeah, it was weird. It was like I'm like nobody did that one.
9.
So it wanted you to actually go. So between 0 and 24.9
Yep.
is within 1 standard deviation, which is 31 out of 33.
Um,
So it's 94% compared to what Chebesky said, which was 75%. So he was correct because he says at least 75%, and we were at 94. So we're good. And even this one, it was 89 compared to actually it's all.
Okay. Yeah.
That's what it was
That
like.
makes sense. So.
That was the piece I was looking for.
All right, thank you.
No problem.
So what was the name of it?
Desmos, DESMOS.
Just a-
Yep, that's the review.
Should we have like a review before the test?
So yeah, so basically next week, I'm going to give you guys about a half hour, depending on how many questions there are, to ask questions on this review. So if you go through and do the review, if there's specific questions, I will answer them, and then we'll go into the test after that.
Okay.
So I figured it's easier to do it that way than do it like tonight and then have you guys do the practice. It's like,
Okay,
I think this way gives you the chance to review, and then we can actually go through some questions.
okay, great, thank you.
No problem. Yes,
Can I get my test?
sure.
Are you going to be here all this week or no?
I will be here tomorrow and Thursday for my other class, but other than that, I will tell you, come my last day of working is November 10th.
What, here too?
No. I'm still teaching here
Okay.
in my high school job. So I will have actually, believe it or not, more time.
Thank you, Lord.
So now I don't really want to drive down here constantly,
I'll
but
go to you. I'll
but-
go to you.
I can come down earlier on Tuesdays and Thursdays before class starts there, which I don't have the ability to do now. So I could technically come down a little bit
And you
earlier.
say 5 o'clock, right?
Yeah, I'm here at 5 o'clock. Yeah.
So I'll email you. then.
Okay.
Okay.
Do you know where the adjunct office is?
Yeah, with the mail, whether you.
Yep, right next to the mailroom. Yep.
Okay.
I'll be right over there.
Thank you.
What was the last name? That was you? Sure. Okay, so you did the same problem that everybody did, don't worry. So what it was asking was, you did the Trubetsky's rule, which is fine for that one. But what you didn't do is you didn't figure out what the actual number was.
Oh, okay. All right. Okay.
So it wanted you to compare it. It wanted you to show that Trubetsky's rule was correct.
Okay.
That, yes, he said he predicted 75% would have been there,
Mhm.
and it actually was 94%. So
Okay.
we were good.
So, all right.
So yeah, that's what I was looking for.
Thank you.
No problem.
What do I need to do the exam?
No, you do not.
Okay.
Oh, that's the only question I got wrong.
There was 3 of you that was the only question you got wrong. Yes.
Question.
Yeah.
On this here, I think
Okay, so your calculator is going to be a little bit of a pain.
I have another one at home, and or should I just use the desk?
You should honestly use Desmos,
I'm
but
gonna stop. When
the
I go home,
difference-
I practice. I'll
so
use it.
here's the difference. So see how your calculator's got 1 line? These calculators have 2. So you can actually type in and see what it is there.
Okay.
So you can do
Yeah.
that minus the 6.05 squared and get the answer. On this
Okay.
one, you have to use parentheses, and it's a
Alright.
pain.
Never
And
mind. I'll just use
actually,
Desktop.
wait,
I'll
maybe not.
practice.
Actually, I take that back. You
Because
do?
there's a square right there's
Oh yeah, you do have to use your parentheses in this because it only shows that it shows you what you're in.
it's old. This is old.
Oh yeah, it is.
God,
but-
this is when I first started back at
hey, you know what? It still works. It's just,
Yeah.
it's not necessarily the easiest one. Yeah, when they added the second line, it makes life so much easier.
Yeah. All right.
So yeah, if you have
I'll
a
practice
newer
at home
one,
with Desmos.
or if you're
I'll
using
check the other
Desmos,
ones.
yeah.
All right.
either way.
You email me?
Yes, I will do it up tomorrow, and I will email you
I
back.
sent you
Jason.
an email just.
Yeah, just remind. Thank you. Yeah, I guess I just got it. Yeah, I'll do it tomorrow after the fair. You're welcome. Okay. So that's there. I don't need that. I do need that. Keep those just in case. Okay, my bag's now a lot lighter.
Yeah. Congratulations.
Thank you. Like it's technically not a retirement because I can't retire until I'm 60, but I'm no longer going to
Early
teach.
retirement.
It's you know what, and everything else that I'm doing, it's no different than retirement. I'm not going to have this actual schedule. I can do my work whenever I want, and I can do other things that I enjoy. Like I told him, I'm
And
like,
your book's gonna be before you know.
absolutely, that's going to be nice. So it's like I can teach winter classes. I can teach classes during the day instead of having to always do it
Were
at
you
night.
teaching during the pandemic?
Uh-huh.
Yeah, see, I was going to start and get this class when I was.
Let me stop this.
I just didn't have too much.
I actually, for anybody who doesn't